Hi everyone, welcome back to Neural Networking with Konverge AI. In today's episode, we have a very special guest straight from one of our very own data partnership firm, Databricks. Please welcome Mr. Rohit Bhagwat, a seasoned expert with a remarkable 2-decade journey in the world of data and business intelligence. Currently, a senior solutions architect at Databricks, Rohit has been instrumental in architecting and delivering innovative solutions that drive data driven transformations. Get ready for a conversation packed with insights, innovation, and real world applications of cutting edge data and AI technologies. Thanks, Rohit, for spending this Monday morning with us. I know Monday, everyone has Monday blues, but thanks for coming and joining us on this podcast. So the first question that I have for you is the Databricks journey. It started with Apache Spark at UC Berkeley. And could you walk us through some of the pivotal moments and when the team identified the need for a unified data analytics platform and how the vision took care from that and how it evolved into Databricks, what it is today?
Sure. By the way, Ketan, Monday mornings are great. This is a beautiful morning out here. So all good. And it's always a pleasure to talk to you. Getting back to Databricks, as you know, I've been with Databricks for 3 years, but I started my career back in 2009, and essentially that's exactly when Spark perhaps started getting more traction, or in fact came to be in 2009. So, from my understanding, although I was not a part, but the story is really captivating, even for Databricks employees who joined recently, that they're always fascinated with the story, but the way it goes, I think back in 2000, or maybe if we go back even early, right? Early 2000s, big data was big. Hadoop was started to become mainstream. Everybody was writing MapReduce. MapReduce was great and everything, but you've spent a ton of time on data science. So these are very iterative sort of tasks, right? MapReduce was not a great sort of solution for that. So the grapevine or the story is in 2009 there was this Netflix competition where they said, hey, we have this recommendation engine. They opened it up and they said, okay, submit your applications, and if you can improve our engine by 10% or more, there's a $1 million cash prize. So that was essentially the one of the things that Spark was something that was being developed by the founder of Spark. I'm sure you must be aware, Mate, who's also a co-founder of Databricks. I think it was his project, but this team of 7 PhD computer science students in UC Berkeley decided, you know what, let's use this Spark and you make this as a distributed general compute sort of engine that not only solves this recommendation engine challenge, but also we can make it more general purpose. That's the background and that's the story. They did end up submitting the application. I think they were either the joint winners or second. I don't know for sure. I'll have to double check. But that's how it started. They realized that, okay, there's a lot of potential because the idea of Spark was pull all that in memory, do the computations in memory. That's the way Spark kind of gets the performance. And distributed meaning you can spin up a big cluster and basically crunch these big numbers on the cluster. So 2009 was when it sort of initiated, and in the next few years they recognized the what changes it can do overall, I think. And then by 2015, I believe Spark was one of the most downloaded open source projects out there. And Databricks was founded in 2013, and they saw that within the enterprise there's a lot of need to consolidate. There's a lot of need to bring this sort of compute or this sort of performance in the enterprise. So I think maybe you can call that as a pivotal moment. So from 2009, recognizing the potential, and the great part as us Databricks guys, we feel is the roots are from the academia, right? As you said, it was at the UC Berkeley. I think the lab was AMP Labs, Algorithms, Machines, and People. So that's a pretty interesting name as well. So that's what I think that's how the journey started. I'm continuously inspired by just listening to the story of the journey.
That's actually great to know. So just following up on that, you mentioned the point of Hadoop versus the Spark, which came into picture. So can you maybe for the audience take one example and highlight like potential 2-3 problems that Hadoop had, and then how that Spark ecosystem came into picture to solve those?
Sure. I mean, I was, by the way, just for my background, like I said, I had started in 2009, and I was working at InfoSeps, and we were supporting a bunch of enterprise clients. So Hadoop for me was new even in 2013 because I did not have a chance to actually work on Hadoop. But later on, when I realized, well, Hadoop was extremely powerful, right? If you looked at the enterprise solutions that typically, in fact, I started with just a SQL server, still one of the more powerful tools, but it's not necessarily known to be supporting large big data workloads. So Hadoop was great for that. You could have distributed data. So HDFS was important. So you were no longer restricted by just the compute that's on your server. So you could expand the server. The challenges with Hadoop and lack of streamlining was MapReduce. Number one, I would say from a challenge perspective, writing MapReduce was very niche.
Yes.
I cannot claim that I've had any experience writing MapReduce. I've looked at systems of people who had written. So I think the challenge of just understanding and implementing MapReduce was challenging. The inner workings of Hadoop was also around how it was like if for machine learning, right? You had to retrain it. You have to run the same sort of data set for different computations multiple times. On Hadoop with MapReduce, that is typically extremely challenging. And that's what Spark sort of simplified. What Spark did was, number one, because the rapid adoption was important, right? Building a community was important. So making the process of actually developing these algorithms or developing on Spark by adoption of community, that became important. And the other thing was just the nature or the architecture of bringing the data in memory and then running processes on it makes it much more simpler to run machine learning sort of algorithms. Back to the recommendation example. So yeah, that's I would say the kind of difference. I mean, let me ask you. I mean, have you also sort of what was your experience? Because I don't know. I think you've done this post graduation in data science, I believe, right?
Yes, I mean, I come from a computer networking and distributed systems background. So for me, I think what we have seen in the enterprises is somewhat similar in the use cases. I think the most amazing value add which was there from a Databricks product point of view was that it was a one-stop solution for all these data science use cases that you could build. So all this before Databricks, the ecosystem which came up was a very difficult task for the programmers. I think that's how it changed the game when the building blocks came together.
Right.
So now I think one is the computational engine that we talked about, Spark, but you also need storage, right? Because you are always working with either structured data sets, unstructured data sets, and you do variety of workloads. So it may range from gigabytes to terabytes of data which is getting generated. So I think at some point of time you could see that the Databricks folks, they realized this, that you needed to have a storage layer in the platform, and a lot of buzz was created around the data lakehouse concept. So can you break down how Databricks approach differs from traditional data warehouses and data lakes, and why this architecture is becoming increasingly crucial for modern enterprises?
Yeah, I think that was you mentioned about being pivotal. I think recognizing that lakehouse is you mentioned the term lakehouse, and I'll maybe expand upon it. But recognizing that lakehouse is the need of the hour, I would say was one of the pivotal movements in the later stages of Databricks. So if you take a step back, right, even if you look at enterprises that I'm sure you're working with, or oftentimes that I interact with, we see that their data ecosystem is just generally complex. It's not their fault. It's just the way things have sort of evolved in the last 15, 20 years, right? So every enterprise you go talk to, you'll have like a warehouse, some sort of a warehouse on-prem or cloud. They'll definitely have a data lake implementation because everybody is doing something with machine learning, and doing machine learning on structured data on a typical RDBMS is, I mean, almost not possible. Then there is a need for like running real-time pipelines. You want to ingest real-time data and still do warehousing on top of it. So what you end up seeing is like there are fragmented systems. There is going to be some sort of a warehouse, some sort of a data lake implementation, some sort of real-time integration, some sort of your own BI tool. What this brings up is a challenge in terms of governance, right? Governance is generally a big challenge. Management and making sure that things are all streamlined, it's difficult, it's fragmented. The people needed, the expertise needed is also so much different. So the idea of Lakehouse was, okay, let's bring the cloud concepts to number one, let's separate the compute from the storage. That's number one. Data Lake sort of brought that, but the challenge was doing any sort of warehousing on that was very difficult. So, for example, if you were writing Spark programs to do any sort of upserts back in 2016, 2017, it was extremely difficult. That was almost like 6 or 7 step process. You would sort of work with the partition, copy the Parquet file, write new Parquet files, and then invalidate the old ones. It was extremely challenging. And that's where the data format came into picture. So we started working on Delta Lake. That was the fundamental aspect of making sure that the Lakehouse vision becomes a reality. So for those who may not be aware, Delta Lake is a completely open source file format that is based on Parquet. Parquet is an open source format. What we do in Delta Lake, and which is one of the most widely adopted open source formats out there in the market today now, is we add metadata to it. So then we can add ACID like compliance on this open format, which was sort of very difficult early before this. So that was the foundation aspect of the Lakehouse. So you have data in an open format that is stored in a cloud object storage. So you could store it in AWS S3, Azure ADLS, or Google Cloud Storage. So then you separate out the storage from the compute, and you have complete control of your data. Then by having this and by also having ACID-like properties, you can then start doing all sorts of workloads: warehousing, machine learning, real time, all sorts of workloads directly on this. So that's the concept of a lakehouse. And then fundamentally, I think at some point we'll also want to talk about Unity Catalog. But the idea of the lakehouse is also going to be, you have one unified layer of governance that makes sure that you're securing your data, but also enabling all these use cases at the top, having the same governance model in place. So instead of having, let's say, grant statements on your tables and IAM roles for your S3 files, you have one interface that governs all your data, and then you can still access it directly using your S3 APIs through Unity Catalog, or using your SQL-like structures through Databricks SQL. So that's I would say Lakehouse was pivotal for Databricks. And by today, I think we started introducing to Lakehouse back in 2018, 2019. Now everybody's talking about the Lakehouse, which is essentially a win-win for the community.
Right. So you could see that Delta Lake, the storage layer where you did the innovation, was a key part or key contribution that was brought on the table. And another
Absolutely.
aspect is the flexibility which you talked about, that it can be deployed on top of the object storage. So that meant that you could deploy it on any of the clouds of your choice. But I want to highlight and ask you about the speed or performance testings, any that you did. Did you discuss that? And how do you see the performance at scale of the Lakehouse?
So there are numerous benchmarks out there, and we've run our individual benchmarks, of course, but even the community has run it. It is, I mean, Delta Lake on Databricks or even on open source Spark has shown performance that beats the best of the warehouses out there. And I can, of course, share the links to these benchmarks. And over the period of the last few years, it's constantly improving and improving. It's like with Delta Lake, originally the idea was, okay, asset transactions, then started being indexing. Then very lately, we've also brought in what we call as liquid clustering, that you don't have to worry about like, hey, do I need to partition data into this physical partitions, or do I let Delta Lake manage it through liquid clustering, so it understands what kind of queries are being issued and then which columns should be clustered by. In fact, we've also brought in things like auto optimization. That's within the Databricks platform. So Lakehouse as a concept not only just works from the flexibility perspective, but also has shown tremendous value in performance and beats most of the performance benchmarks out there.
Nice.
Yeah.
Now coming to the governance aspects of data, so we already know that you have Unity Catalog, which has become a cornerstone of data governance in the Databricks ecosystem. Like you explained the Delta Lake and the Lakehouse, can you also explain how it's helping organizations manage the data assets at scale, particularly since we are talking about AI slash generative AI, where data has now become the most important thing in an organization?
Yeah. Now, this is my personal opinion. I think Unity Catalog is one of the superpower that Databricks as a platform has. Unity Catalog was again very fundamental to realize this vision of a lakehouse. Right? You need to have a unified governance layer. And I think we introduced this in 2021. Again, sometimes I end up talking too much about history, but it's important to understand where it's coming from a context point of view. Unity Catalog, number one, is more than just governance. Right? What Unity Catalog within Databricks gives you is, of course, it gives you all the permissioning models, so you can govern your data sets, you can govern your users. Unity Catalog also gives you lineage. So any workloads that you run on Databricks, we capture detailed lineage in Unity Catalog and surface it through your UI, and also available through your API, so that you can integrate with other tools of your choice if you have. It also brings auditing. It also gives you ability around monitoring and data quality of the assets. So Unity Catalog, like I said, is a superpower. Which number one, it gives you one unified permissioning model that you can apply on all the data. So now in Databricks, you can expose your data through Delta tables. We also have support for Iceberg through this thing called Uniform as an example. You can govern your assets using Unity Catalog in the most simplistic manner. If you've spent any time on AWS or Azure, one thing that I always struggle with is just those difficulty of managing IAM permissions at the S3 bucket level. You then have the roles out there. It is difficult, maybe for somebody who comes from a database sort of background. For somebody like me, right? We came from a background, or I came from a background. It was very simple. You say, hey, grant, select on
So
this
you
table.
could
It was
do the
simple to
row
understand.
level and column level as well.
You do the row level, exactly. Same thing in Unity Catalog. We give you the same APIs that are extremely easy to understand. Give you the same level of flexibility, so you can still do the grant, select on. You can also apply row level security, column level masking, and then apply it to user groups. The best part is it gets applied to tables. So when you're using it through SQL, it gets applied. When you're using it through machine learning interfaces where you're reading it in batches and then running algorithms on it, we still apply the same use cases. And you mentioned Gen AI. When you build these compound AI systems where you're supporting these RAG-based applications, even during the access, we make sure that the vector databases that are being queried will also get applied the same security that we've declared in Unity Catalog. Right. So yeah, extremely powerful. And not to mention, not to forget, it was open source last year. So it's Unity Catalog was open source last year. So more and more features that were only within Unity Databricks are now in open source. I think they're slowly making sure that the parity between the open source and what we have gets to the same level. But what that is given is the APIs are now more and more accessible for people to use and leverage and build their own sort of ecosystem on top of it. So that makes it extremely important. So what I look forward is, maybe I'm jumping, but what I also look forward is our support for Iceberg. So we also have within Unity Catalog, make sure that you no longer just required to use Delta Lake. You can also use Iceberg tables and expose it to other systems. So I'm really excited to really see that all these system that we say open is actually completely open for you to choose any sort of format that you may have. So, yeah.
I think it also would be interesting to see what features people come up with in Unity Catalog based on their requirements. Whenever you have such a strong project being open source or a product being open source, there is always a contribution which you always are looking for from the community, which comes in as sort of features, and then you understand that okay, hey, these are maybe the three ones that we did not think of as a team that people wanted in the product.
Yeah. I forgot to mention, I think because we discussed about open source, the delta sharing, which is again an open source protocol that powers most of the marketplace data or even the data sharing between different customers, is also implemented by Unity Catalog. It's an open source protocol, but with Unity Catalog, you get that sort of a free, so you don't have to manage your own delta sharing protocol server or anything like that. So that is, from a use case perspective, I'm seeing a lot of interest from a lot of my customers, at least, to understand how delta sharing is going to work, how they can share their data,
with all the
not just within the organization, but outside the organizations. And Unity Catalog is also playing a very key role in that area.
Right. Nice. Now coming to the AI part of it, because we cannot miss on AI slash Gen AI. I think the most crucial thing for a developer is when the model goes into production is to see how the model is performing. That is one, whether it's performing according to the KPIs, as per the business use case, it may be accuracy or precision, whatever it is. And also to be able to debug the model whenever there are problems in production based on the production data which is getting interaction with the models. So MLflow is something which made it possible for the developers actually to take a holistic view of debugging, as well as having that governance parameters being shown in real time in production, which was of great help. So I just wanted to dive into MLflow and how has its integration into Databricks ecosystem transformed the machine learning lifecycle for organizations, and what key challenges does it address for you?
So MLflow is also one of the open source projects that was created by the same people, and in this case, Mate, back in 2018. It came into existence to solve the main challenge that, okay, everybody was doing machine learning, but the overall ecosystem was, again, extremely fragmented. What most of the data scientists were doing was taking data getting some sort of access to the data, running hundreds of experiments, and then they would maybe maintain an Excel sheet or a Google sheet managing, okay, what were the experiments that were run, what were the metrics, what were the parameters, or they had their own sort of homegrown frameworks to manage all the different experiments and track these experiments, manage the models. The other difficulty was there were a lot of model frameworks, right? You have PyTorch, you have scikit-learn, you have TensorFlow. There was lack of compatibility between them, like how you serve those models. So there are different model flavors that you end up creating, and it becomes challenging to then deploy these models. Or when I say challenging, everybody has their own sort of mechanisms to deploy these frameworks. So interoperability between these frameworks also was a challenge. So MLflow was created to address a lot of these. So number one, MLflow has, I think, 3 or 4 key aspects. Number one is tracking. So when you're running any experiments, you can log all the metrics, parameters, custom metrics, custom parameters. Number one, so that's that. So it has a tracking server. Then you also have the model registry. So you give one sort of way to register your models, and all these models are then stored as pickle files, and then that way you can deploy it in a unified manner. And then I'm forgetting the other couple of aspects, but the main thing is you get one unified interface that tracks, and then you can register the models. And that's what the MLflow project, which is completely open source, the idea of it being managing your end-to-end machine learning lifecycle. So MLflow, think of it as DevOps for machine learning. So that was the idea of MLflow. It was open source, and now it's deeply integrated into Databricks as a platform. And by the way, MLflow is also the same, even on Azure machine learning stack, MLflow is the one that empowers behind the scenes. So MLflow is really integral to a lot of these machine learning sort of implementations across different ecosystems.
Just picking on the point of model registry, I think that is a feature which really stands out for me as a developer, because there
Yeah.
was in machine learning what happens, like you pointed out, that you need to do hundreds of experiments, and when you are doing hundreds of experiments, you are playing at least for one business use case with 3 to 4 different models, and you are trying
Yeah.
to check how the models are working on the data set that you have. And previously there was no model repository, like you have a code
Right.
repository where you could have a
Right.
registry, and then you could quickly change the models in your code, and the underlying framework, it didn't matter for you. So I think this
Right.
is something which really I see that has helped developers.
Yeah, I couldn't have said it better. Exactly. And then within the Databricks platform itself, now getting into specific to Databricks, now how it's integrated with Unity Catalog also becomes important. So now, as you're developing models, a couple of things that stand out from Unity Catalog perspective, you can have multiple models. So you can register all these models in Unity Catalog, and you have that ability to access those models from all the different workspaces. So you're no longer tied to using the models that are only within the workspace or that model registry of the workspace. Then you can start doing this challenger champion sort of model evaluations by, and then it's also integrated with Databricks feature store and our serving capabilities. So if you're using feature store or feature engineering client and you're deploying models using our feature store capability, the best part is the model knows what tables need to be joined at real time. So you don't need to worry about that when you're actually, if you require inferencing or real time inference, you can just pass on, like, for example, a customer ID, and the customer churn model behind the scenes will make sure that, okay, it can join on the customer ID table to get all the features necessary to get the model output out there. So it's tightly integrated, and you can serve the model using model serving. So we also have GPU serving, we have CPU serving. Traditionally, you can scale to zero. So all these model serving capabilities are nicely integrated and all talk to Unity Catalog. I keep bringing Unity Catalog because I think I'm really
I
excited
think,
about what it is.
yeah, no, that's a very what you say, the pivotal part to all these different nodes that we have. We are talking
Yeah.
about, be it the Delta Lake or the Lake House, where there is data, there is code in the notebooks, and then MLflow. So I think this central fulcrum point that we talk about, it's the Unity Catalog, which makes it what you say, possible for all these things to happen. Now we talked about serving the registries, the code. So you have to, at the end of the day, orchestrate everything together in a
Yeah.
nice manner, so that you are able to do the production workloads. So with the rise of generative AI, how is Databricks approaching the orchestration of AI workflows, and what does the agentic AI role play in your platform's evolution?
Yeah, and individually, this is an area that I am really excited about, and I try to at least keep learning the advancements in this area, which are extremely fast, and you almost feel like what you read last week is probably already old news. So that's that. I'm sorry, that was my daughter right there. Yeah, on the Gen AI bit, what our thought process is, we want to enable enterprises to productionize these Gen AI applications. I think ideas. So right now, it's very easy to get started and maybe build a POC, but where it becomes challenging is how to productionize this. Exactly to what your point is. So our approach is like to make sure enterprises are able to completely productionize and scale their generative AI applications. So we've been coming up with multiple things. So I think if you may be aware, we acquired Mosaic AI a couple of years ago. So they had the expertise of pre-training from scratch and in an extremely cost-effective manner. So that was one of the key points for us to acquire Mosaic AI, to bring those capabilities to completely pre-train or fine-tune the models. But even before that, now what we have is, number one, we want you to have the flexibility. We want the enterprises to have the flexibility to use any models. So we have a concept called AI Gateway that gives you one unified interface to query your LLMs, and then you can switch any LLM behind the scenes, right? So you can use OpenAI as or you can have your own like large language model implementation, or you could use Llama, or you can use like fine-tuned version of Llama. So you can get complete flexibility. And what we offer is the ability to make sure that we have rate limiting, we have safety guards applied. So all those typical challenges that you will see when you serve, that is already taken care of by AI Gateway. We also give you the ability to say, hey, these set of traffic goes to this LLM, the other set of traffic goes to the other endpoint, as an example. So complete flexibility, complete control on what model that you want to use. Then again, Unity Catalog plays a key role then. So now agentic applications. The agents, meaning what you want is you want to build compound AI systems. So you don't want general intelligence, you want intelligence on your data. So for that, you want to be able to build agents that can interact with your data. So that may be function calling, that may be querying your data, text to SQL sort of use cases. So we enable you to build functions and define them within Unity Catalog. So those functions can be executed in a secure environment. We use serverless behind the scenes. And then you can then use agents to call these functions. So then you can deploy, and all this can be done very easily in literally seconds, because what we give you the playground where you can start playing with functions that you've defined and then integrating that with your models. So then you can start building agents and deploying these agents. So number one, choose your model. Number two, complete flexibility around defining those functions and creating those agents on top of it. The number three is serving those agents. So we have model serving capabilities that let you serve those agents and deploy those as like I said, on GPU, or you could do it through provision throughput, or if you want to use foundation models like Llama, you could also do that. Or you can of course simply just access your OpenAI models or Google Gemini models as well. But because of our acquisition of Mosaic AI, just to finish the point, the other thing is also we want you to have the ability to constantly monitor the results of applications. So everything that you're then deploying within Databricks, every request and the response are being tracked. So then you can then further analyze it. You can then build your own data set based on the request responses and then fine tune your model. And then instead of using a foundation model, you use a fine tuned version of your model. So all that is also getting integrated into what we call as LLM ops. So which is now nicely getting more and more integrated with ML ops in general. So I mean, if I have to give you in a nutshell, we want, like I said, we want enterprises to have full flexibility and full control over the generative AI applications that they build. And the application should be nicely, tightly integrated with the data ecosystem, having the same permissioning model across the board without you having to kind of worry about that. So that's our vision. That's how our platform is growing.
Very excited to see how the agentic part evolves. As you correctly pointed out that in the morning it's a different thing in the technology space. In the evening it has already been changed. So we all have to play the catching up game. Yes, yes. So when working with, I know you work with a lot of enterprise clients and help them build the solution architectures for the business use cases. So what are the most common use cases you are observing, and how does Databricks help organizations build their data platform strategy from the ground up?
No, I'll tell you from my personal. I think as a Databricks, it's difficult for me to speak as a whole, but I'll say that hey, I am personally work on the retail vertical. I want to categorize what I see typically in two areas. Number one is just supporting the business, and there's lots of use cases that people want to build, like just, for example, demand forecasting. Right now, I'm working with multiple customers who try to get to that demand forecasting in the most accurate sort of manner, but at the same time at the most cost effective, right? Then there are this text to SQL use cases. There is, of course, always making sure that you want to understand your customer better. So customer data platform. So all these business areas that want to do that want to address specific business challenges. But then to your point, like how does Databricks? I think the other area is the IT area, right? Where the IT leadership wants to modernize the stack. The number one challenge, like I mentioned previously, was being able to consolidate. It's just very difficult to maintain all these different platforms, and not just Databricks. Anything they want to be able to consolidate. So that is one of the key things that I see a whole lot across the board. So being able to modernize within the retail vertical, at least, I still see a lot of migration still active. Like there's still a lot of on-prem that enterprises want to get out of and move to the cloud paradigm, because cloud gives you flexibility, scaling, so all the benefits of the cloud. And then from a data perspective, I would say something that excites me a lot, like a lot of enterprises that I work with, is they want to streamline the ingestion and the transformation frameworks. They want to have a framework around, like, you can have any sort of like source data. You want one unified framework to bring that data in, so that then you have it in within your lakehouse. So then you can kind of enable all these different business use cases that I was mentioning. So yeah, two categories: the IT category that wants to consolidate the tech stack, the business category, of course, wants to build stuff faster, and then they want the IT to support them as soon as possible. So yeah, that's at a high level what I see. I know you also work with a lot of customers. I'd love to hear from you as well, like not just retail. Like, what sort of things do you see in your customer?
I think what we are observing are three buckets of use cases. Like you also said about two buckets. One is the migration use case that you talked about, and the other being the demand forecasting or any kind of anomaly detection or any kind of customer data platforms where you understand the customers. So like that, what we are observing are three buckets. One is from a business perspective, what the CXO leadership is looking at is how fast they can get access to the data, business data, so that they are able to make the right decision. So this is one category. Now the underlying tech can be different for different instances. So it can be like sourcing the data from databases or warehouses and the lake houses, and showing it in a Power BI or a Tableau dashboard. It can be as simple as that. Two, it can also be as complex as building a RAG pipeline on an unstructured data to get the information on fingertips to the CXO leadership. So this is one category. The second category is for the CXO -1 or the -2 leadership teams, where they are looking at more operational side of things, where they want to bring a lot of efficiency in the processes. So that is the second thing, where you kind of analyze the data for streamlining the operations. So now the underlying tech again can be as simple as what you say, doing a forecast on a sales of a product, to as complex as identifying risks in the supply chain from a demand forecasting perspective for 2000 plus products. So there is a simple, medium, and complex kind of category of problems or the tech that you are trying to bring in. And the third category of usage is, apart from bringing the data for the CXO leadership for the decision making to the operational efficiencies of CXO -1, -2, or -3 levels, is innovation use cases for the customer facing side of things. So where people are trying to build as simple as a customer facing bot which is powered by the large language models to enable new customers to get to know how about the products of the company, to as complex as replying to the complex tickets that the customers have come up with in the customer support environment, or building as complex as hyper personalized marketing content generative AI pipelines for the customer. So I think these are the three major categories of buckets of use cases that we are solving for the customers. One being from the CXO leadership perspective, the second being from the operational perspective, and the third being from the customer perspective.
Right.
Yes.
That's a great way to explain like how enterprises are thinking of solving simple, medium, complex challenges, and
Yes,
that's great. Thanks.
yes. So now coming to the last questions, a lot of organizations. You also mentioned that migration in the retail space you are observing, and they are trying to invest into modern data platforms or modernize the stacks.
Yeah.
Now there is always a thing between as you also pointed out, there are business folks and there are IT folks, and
Yeah.
in order to get the buy-in for the use cases, you need to go to the leadership and secure the buying. So for that, what advice do you have for building a compelling business use case and securing that leadership buy-in for the folks?
I'd love to try to answer. Again, I don't know if I'm the best person to answer this question. Anyway, I'm more of a tech lens guy, but I
Yes.
think what I've learned in my last few years is number one is value. Right, make sure that you're able to articulate value, and the only way to articulate value is if you are able to tie your sort of strategy to your organizational strategies. Like I'm sure, like any enterprise that you work with, they have a business strategy. I love to kind of just understand, listen in on their earnings call if they're a public company, and understand, okay, where are they really investing in the next year or two, and then maybe work with your counterparts in the on the IT side to say, okay, if this is the KPI, these are the sort of use cases that can be tied to that KPI that our platform can help you build, because that's something that as an organization, that's the focus that you may have. So you can help your sort of liaisons on the enterprises to say tie into the organizational KPIs, tie into the organizational vision, and then articulate the value of the solutions that can help you get there. That's a super high level, I'd say. And one thing I would say is I'm still learning. That's a skill that I think I can get better at. But that's my like 2 cents. Yeah.
There are a lot of folks who want to enter into this Databricks or data and AI ecosystem and
Mhm.
become solution architects. So I would also like you to ask, what would be your top three things that if someone who's coming from we used to have these roles, right? The database administrator roles where people were
Yeah.
very good at either an Oracle or a PL SQL or a database kind of things, and you see that a lot of folks from there they want to transition. Some of them they try to transition into an Informatica role or some other tools they learn, and if they want to come into the solution architect bracket and enter this Databricks slash data and AI ecosystem, so what are the top three things that they would need to enter into this ecosystem?
That's a great question. Let me have a think. So I think this is a great time to get into this ecosystem. I think it's no longer at a place where it's like almost feels extremely complicated. Like, hey, I don't know how Hadoop works. I don't know how HDFS works. I think things are, I mean, because RDBMS has been there for 30, 40, 50 years, I think from a knowledge perspective, there is a lot of knowledge out there. I think similarly, these systems or Databricks or any of these cloud systems have now become more and more mature, where the entry point is not that difficult. You don't need to be an expert or a PhD to just understand how things work. But having said that, I'd say number one is upskilling. I think understanding the overall cloud ecosystem, understanding all the three hyperscalers that you have, how they work from a very like architecture perspective. I think that's great. From a upskilling perspective, understanding the data ecosystem, like I said, like, hey, what are the open formats? What does really Delta Lake mean? What is a Parquet file? So understanding the basics of what's the difference between traditional warehouses, lake houses, data lakes, etc. So upskilling in that area. So that means upskilling on the cloud, upskilling on this data ecosystem that's more like, let's just say, quote unquote, modern data ecosystem. And then if they want to, I think having a grasp of any one programming language will always help you. And I think that's something that I would say for anybody in this world, like just understanding how to program is a skill that will only benefit you, in my opinion, anyway. I mean, pick up a language of your choice. Python is a great way to get started. It's relatively simple. Um, I'm not a person who can write C++, so I won't even say that. But I mean,
Yes.
in the data ecosystem, I think Python's a great language from a programming perspective to understand. And I think, yeah, I mean, upskilling, constantly making sure that you're testing yourself and thinking and you also asked about solution architect, right? I think solution architect is a unique role, which is like in the middle between, there lies on with the business, where you want to understand, hey, the solution that you're building, is it going to be scalable? Is it going to be something that you really want to? Are you overcomplicating it? Are you simplifying it? Is it really addressing the challenge or business problem that you have, or you're just doing it for the sake of,
Sake of doing
you
it.
know what, I like to have all these things on my resume, so I'm going to use an Airflow, and then I'm going to use this Lambda to trigger this, where you could have simply done it in a single sort of, I don't know, single job.
Yes.
So having that ability to have a broader lens, trying to connect the business problem with the technical solution, I think that's a unique skill, like I mentioned to you. So that's something, as a solution architect, is a key skill to have. So it's not always just about being able to write these 1,000-line code for a
Right.
workflow, but also tying it to the business problem and thinking holistically.
I think from my end, I feel that a mature solution architect is the one who understands that you don't need a thermonuclear device to kill a mosquito.
Yeah, that's
That's a way of,
very well
putting.
said.
Yes. So on that note, thanks a lot, Rohit, for joining us on the podcast. Really appreciate you and really appreciate that you spending time with us. And of course, we'll be doing some more episodes with you in the future. Looking forward to that. Thank you. Thank you.
Yeah, it was wonderful talking to you. Appreciate it. You calling me, and I really had a fun time talking to you. And I'm sure I look forward to more of these going forward.
Yes. Thank you. Thank you.